Let's look at a squeeze theorem problem with something that looks pretty complicated, but is really similar to what we've been working with all along. We see that we've got a trig function in our limit problem, which should be the giveaway that we need to use the squeeze theorem, other than the fact that they say use the squeeze theorem. So remember, with these sorts of problems, they're very formulaic. We can start with sine of x, right? That's the trig function that's giving us problems. And we can say that, sine is bounded by -1 and 1. If we want to be a little bit more efficient, we can actually start with sine squared of x, which you might realize is bounded by 0 and 1, right? Because when something's squared, it's not negative. If you write -1 in this case, then you'll probably be okay. It shouldn't affect your final answer. It's just 0 is a more precise bound, lower bound. Okay, anyway, let's continue. We want to go from this to this. So we're just going to first add 2 to both sides. Okay. Next up, we should probably multiply by x squared. And in fact, we can even multiply by x squared divided by x cubed plus 100, right? Let's see. We're going to get 2x squared over x cubed plus 100 less than or equal to, the original function. And then here, we're just going to get 3x squared over x cubed plus 100. All right, so now we have our lower bound, our upper bound, and our original function. Okay, next up, we just need to confirm that the lower bound and the upper bound have the same limit, and we will see that they do. All right, note that the limit as x approaches infinity of 2x squared over x cubed plus 100 equals, well, I guess that's infinity over infinity. We do it out. But maybe what we can do is we can multiply by 1 over x squared, the top, and to the bottom. So that gives us the limit as x approaches infinity of 2 over x plus 100 over x squared. And I think that pretty clearly equals 0, right, because of this x down there. Top stays the same, bottom gets big. And, well, analogously, the same thing applies to, 3x squared over x cubed plus 100. Except we've got a 3 instead of a 2 right up here. Right, and again, we get 0. And so remember, finishing touches. By the squeeze theorem, please make sure to write that in a complete sentence. We have that the limit as x approaches infinity of this complicated looking thing, because it is complicated, equals 0, right? Complicated, but no more complicated to solve than any of the other squeeze theorem problems we did.